Sir. So without wasting time, we will just shift on to the topic that EIP Enviro Level Controls Private Limited is offering for today, which is basically fly ash handling and some unique solutions. So the challenge one, we will talk about the FG duct. I will just request Mr. Rajat to just brief about the challenges being faced in a flue gas duct. Over to you, Rajat.
Thank you, Abhishek. First of all, good morning to everyone. We will move to one of the first challenges. What we have achieved a solution to the customer for FG duct. FG duct is basically duct between boiler to ESP, and this solution, what we'll be discussing, we have provided in power plants with capacity of 500 megawatt and above. So what happens is, in generally uh, plants with a capacity of 500 and above, the ash traveling from boiler to ESP, the duct, the velocity of ash is very less when the plant is not operating at a full load. Because of such operation, the ash accumulation takes place in this FG duct, and we observed that the ash accumulation was so much, like the duct is of height 7 meters and the accumulation was around 4 to 5 meters, and because of such accumulation, the sagging of duct took place. In fact, in some of the plants it was observed that it is around 400 to 500 mm. So because of such sagging, there was a need of immediate solution to monitor the ash accumulation and monitor the what amount of ash is there and how we can do the maintenance on continuous basis for such a accumulation. For such FG ducts, we have this in various plants of government plants. This was observed. We provided a very good solution to this FG duct problem, and now I'll hand over to Abhishek. He will explain in more detail how we provided a very good solution for this FG duct application and how we provided a 3D profile and measurement solution for this.
Sir, like Rajat already explained, what is the challenge in FG duct? There is ash accumulation when the plant is running on lower load, and there are various reasons for plant running on lower load. In fact, the upcoming scenario which says that the coal-fired power plant will be running in sync with the solar-fired power plant. So during that protocol, there is a design wherein during the day the plant coal-fired power plant load will be reduced as solar would be taking up, and during nighttime coal-fired power plant will bring up. So that will lead to the speed velocities within FG duct to be very slow and fast, varying upon the capacity and the load. So what happens when ash accumulates in a FG duct? Why is it very critical? The reason is the ash always accumulates in an uneven profile. There will be a lot of dust and there will be maintenance issues and very high temperature to the tune of 350 degrees Celsius. So what is the solution that we offer is a 3D radar level transmitter. So there are 4 critical points in the FG duct starting from the boiler to the ESP. There are 4 critical points wherein the ash accumulates the most. Therein we will install our 3D radar level transmitter, which is the world's first multi-beam radar operating at a frequency of 140 gigahertz. What it provides is the average level of the ash accumulated within that critical point, what is the maximum level of the ash accumulated, minimum level, and the volume of ash within that critical area of the FG duct. It works in heavy dust without air purge and works at very high temperature. We have even used these radars for as high as 1200 degrees Celsius. So a temperature of 350 degrees Celsius is easily manageable. So let us now just have a look at the basically structure of a FG duct, how it looks like and what are the critical points. And there's a real-time picture of an inside of the FG duct, and you can see the amount of ash being accumulated. So there's the amount of ash you can see is accumulated, and this causes the sagging of the duct because it has no support from the bottom. This is the 3D radar level transmitter being installed in this FG duct. And you can see the real-time 3D profile of the material. You can see the variability in the profile from the right side wherein it is low height to a high end side. So you can see over here, the minimum level is 1.4 meters and the maximum level is to the tune of 2.88 meter. You can imagine a duct which has a height of 7 meters, a 2.88 elevation of ash accumulation is too high and it puts a mechanical load on the FG duct. So this, in fact, is one of the most unique solutions we are offering for ash handling plant these days with the FG duct level measurement. Now we come to the challenge 2, which is basically fly ash silo level. So people usually ask us, why is it critical to measure fly ash level? The reason is fly ash these days is revenue. And as they say, a penny saved is a penny earned. So the inventory management of fly ash, if that can be regulated, is something that is a direct revenue to the plant, because we are selling the fly ash to cement plants and other process units. Now, again, the fly ash measurement, as for any bulk solid, is critical because fly ash always is accumulated in an uneven way. There is a lot of dust inside a fly ash silo, and there are multiple maintenance issues. And added to that is the fly ash silos almost 24 hours running. There is filling or emptying, something or the other process always going on. So you cannot miss to have a reading of inventory, and you cannot miss a shutdown being caused due to a level transmitter in a fly ash silo. So the solution again remains the 3D radar level transmitter, which I've already explained the features about. On the right side of the screen, you see how a 3D radar level transmitter would be working in a fly ash silo. Is it has 5 beams in different directions. Using these 5 beams, I'm actually able to generate a real-time 3D profile of the material, because it has XYZ coordinates of those 5 points. Joining them, we get a real-time profile of the material. So this is a real-time screenshot of a 3D radar level transmitter being installed in a fly ash silo, and you can see the profile unevenness in this silo. This is again a silo. There's not a fly ash silo per se. There's a very big clinker silo, and you can see we have 3 numbers of 3D radar level transmitters installed to generate a real-time 3D profile. As the world is currently moving towards complete 3D profile management for various activities, so we also say that why not do a complete 3D profile assessment of bulk solids and powders, because this gives you a lot of information about your inventory. And obviously, you have the volume and you have the mass at hand at all times. Now, let us have a look at a small video on the 3D radar level transmitter. So this is so as I said, this is at 140 gigahertz, and so you see this is a single beam measurement. You can see the kind of error you may be having because of a rat hole that is formed, something like this. Now, if you have a 3D radar level transmitter installed in the same silo, you will be having a profile which is real time in nature, and you can see on the left side the profile is generated just like what is shown on the silo. And when you do a comparison, you can achieve very high accuracies to the tune of 2 to 3% when you use a 3D radar level transmitter when compared to a single beam radar level transmitter. There's a real screenshot, real live video wherein we have a silo, and you can see, you can move the 3D profile and actually see how the material is taking shape within the FG duct or a fly ash silo. So these are 2 sensors being installed in the same silo. You can easily imagine if I have a single beam radar, how uneven my readings would be. So now I will move on to a next unique challenge, which is very close to the heart of EIP. Why I say heart of EIP is because EIP started the business with ESP fly ash hopper level measurement. We mentioned the RF level switch, which 80% of the power plants in India are using. EIP make RF level switches. And 100% of the power plants have a mandatory requirement of a ESP ash level indicator or a RF level switch. So this topic is very close to our heart because we understand that ESP measurement, level measurement, is very critical. And why do we say it is critical? The reason is in front of us in terms of the recent accidents where we have witnessed ESPs being collapsing in well established big power plants. Current measurement is only a switch. A switch gives a high and low level. You never know what is happening apart from that high or low level. Then other critical point is that the evacuation right now in ESP hoppers is on a timer mode, whereas it should actually be on a case to case basis. Whenever the hopper fills, I should evacuate that hopper. It should not be on a timer mode, because a timer mode of operation is a heavy cost that is involved in the operation to the plant. Then again, the fourth point of criticality is whatever measurement principles we are using are intrusive type. What I mean intrusive is it is installed within the ESP hopper. Anything that is installed within the ESP hopper is prone to wear and tear. The reason being, the ash has a high temperature. The fly ash in ESP hopper is high temperature. There is a lot of electrostatic charge, and plus ash has its own abrasive nature. So these all points make it very critical to have a very robust system for ESP ash hopper level measurement. Now, what is the solution? The solution is a NOGS sensor which provides continuous level inside a ESP hopper. Yes, it is a continuous level transmitter within the ESP hopper. And how it is installed? So if you see the blue picture over here, this is the NOGS sensor, and it is installed 30 to 50 mm away from the aluminum cladding. So this, what you see over here, the point number 3 is the wall of the ESP. Serial number 2 is the insulation layer, and outside 5 is basically the cladding. So you see this cladding, this NOGS sensor is installed outside the cladding, which means there is no cutout, no shutdown required for installation. This is amazing because you're installing something outside the hopper, absolutely outside. Now you would be wondering, how is something able to work or make a sense of ash level inside the hopper when it is installed completely outside? So let us look at the phenomena or the principle behind it. The principle is very simple, which says that this sensor, the NOGS sensor, detects the gamma ions which are present in the fly ash. Yes, the coal fly ash is radioactive. There is a separate theory which says why coal ash is radioactive. You can just send us an email post the presentation if you want a theory or a scientific literature on that. But as of now, let us focus on the fact that my coal fly ash has radioactive particles, radioactive gamma ions, and my NOGS sensor is only detecting those gamma ions. So there is no source involved, no external source. My fly ash is radioactive, and my NOGS sensor is able to detect that gamma ions to generate a continuous level. The quantum of fly ash is proportional to the quantum of gamma ions, which is proportional to the quantum of level detected by this NOGS sensor. So this is the theory behind this NOGS sensor. So you see, this is completely non-invasive continuous level measurement. Fly ash can do absolutely no harm to this sensor. It is easy to calibrate, easy to use. It is what we say, it is like your eyes inside a ESP hopper. So you can now virtually see what is inside the ESP hopper in a continuous measurement through this NOGS sensor, and you can practically operate your evacuation mode on this NOGS sensor. So what we say is the evacuation now is running on an NOGS mode. NOGS mode is wherein this NOGS sensor gives you a feedback automatically, yes, this hopper needs to be evacuated. This is truly and truly a cost saving benefit wherein you can realize the return on investment from day one of installation of this NOGS sensor in the fly ash hopper. So let us look at few of the installations. So you see, this is installation from one of the power plants in India, and you see this is validating the fact that this is installed outside the hopper. You just have a steel angle and it is installed outside the cladding. Just let us have a close up. So you can see it is installed outside and you have a continuous level measurement. So right now it says it is 33.4%. So you have a continuous gradation of level inside the ESP hopper. So now let us move on to challenge 4. So challenge 4 we say is buffer hopper level measurement. Again, buffer hopper is the intermediate transit hopper wherein overfilling and underfilling are critical problems and is something that is operating at a very fast speed. It fills up very fast, empties very fast, and it is in continuous operation. So the challenge of buffer hopper remains the same like fly ash, dust, maintenance, 24-hour active, and high temperature. And adding to that is high pressure inside a buffer hopper. So what is the solution that we offer? Because a buffer hopper is very small, maybe 3-4 meters. Going with the 3D radar technology may not be always advisable for a buffer hopper given its size. So we have this 140 gigahertz radar level transmitter being installed in the buffer hopper. Again, it is at a frequency of 140 gigahertz and it is the world's smallest beam angle radar, which is at 2 degrees, works in heavy dust without air purge, with a very high temperature, and even can pass through a blind PTFE. So yes, this is a fact that is to be noticed. If you see this sensor on the in the center, which is a small sensor, this one, if you place a PTFE disc below this sensor, a blind, the rays can pass through it and get back through it. So this is the kind of accuracy with which and the power with which this radar level transmitter works. So I'll just share my screen once again because I have a video which I want to share, and I think just a second. Share computer sound. Just a second. Just a second, sir. I'm just. Yeah, is the screen visible, sir? Rajat, screen is visible?
Yes, yes.
Yes, sir. Yes, sir. Screen is visible, sir. Yeah.
So this is, I wanted to show a video. Is the voice coming?
Yeah, it's coming.
Voice is coming. So,
Yes,
sir,
sir.
this is an installation of this kind of a radar being installed not in a power plant, but we have installed at a temperature of 1200 degrees Celsius. And like I said, it is working in such a stringent condition. So you can see there is dust, there is fumes, there is temperature, and this radar level transmitter is giving an accuracy close to 2 to 3 mm within this environment. This is basically the molten metal being poured inside a vessel, and you can imagine if something is working in this stringent an environment, it is supposed to work in a buffer hopper. So this was a small video of how to show that this 140 gigahertz radar level transmitter is the most optimal device to be installed for a buffer hopper level measurement. Now we come to challenge 5, which is density measurement of wet ash slurry. So this is applicable for power plants which are having wet slurry discharge. And why is density measurement of wet ash slurry important? Because if the slurry is too dilute, there is loss of water. And if the slurry is thick, we have chances of pipe choking. These are very brief, very gross level criticalities for ash slurry measurement. And what are the current density measurement challenges being faced by the industry is the density measurement which is actually working easily are the wetted and contact type. But the problem with wetted or contact type is it does not last long in ash slurry. Ash slurry is very abrasive, it damages the sensor, it chokes the sensor, it chokes a inline density meter. So whatever technology we may ask an orifice type of flow density or a Coriolis type or a vibration type, whichever type of contact type density meter you may want to use, it does not work for long and practically of no use. The only solution that is coming to the industry as a non-contact type currently is nucleonic type. But the nucleonic type has its own problem. It has AERB restrictions. There is license for usage. You might be needing a radiation scientific officer. You need to submit every half yearly a report. And there are chances of frequent surprise inspections by AERB. And the reason behind all of this is the source being used is cesium 137, which has a radioactivity of 1.5 gigabecquerel or 20 millicuries. We will go on to the next slide to realize the importance of this 20 millicurie. But as of now, I just request you to remember this figure of 20 millicurie. So this 20 millicurie is a health hazard, and that is why AERB is putting so many restrictions. We have cases in power plants wherein the density meter has been ordered in 2015 and it is 2020. The density meter is yet not supplied. The reason, AERB has still not given approvals for installing the density meter. The license has not been awarded by AERB. If you're going to use 5 density meters in a plant, you need approval for 5 of them. You need an NOC. And there are cases where the density meter is still. And who is the end use sufferer? Sufferer is the project supplier and the customer, because the project supply for the project supplier, the project is not getting closed, and for the end user, they are not able to get the density. And this is the reason. So what is the EIP solution for this? So we have two unique solutions. First is sodium 22 based non-contact nucleonic density meter. Yes, it's a nucleonic density meter, but it uses sodium 22 as a source, which is AERB exempted. And why is it AERB exempted? Because the source strength is 700 kilobecquerel or 0.020 millicurie. I'll just move on to next slide to show you this was 20 millicurie and 1.5 gigabecquerel. This is 0.020 millicurie. So it is almost 1/1000th of the strength of what is conventional, and 700 kilobecquerel is, you can compare giga and kilo. So that's the kind of difference. So there is no license requirement for procurement and usage. There is no reporting, no RSO. It is completely safe. You can even hold the source button source in your hand for 10 minutes. I will show you in the next slide what this means to hold a source in your hand. The second solution that we have is ultrasonic clamp-on slurry density meter. Yes, you have heard of ultrasonic clamp-on flow transmitter, but we have introduced an ultrasonic clamp-on slurry density meter. So it is working on the principle of a sender and receiver ultrasonic waves, wherein the attenuation of the ultrasonic waves gives an accuracy as good as a nucleonic device. So density measurement can be done as accurately as a nucleonic device. It is mounted outside the pipe. Now the question come up, which device to use? So basically this is an application problem which we request customers to generally send us the application details, like the size, diameter of the pipe, size of the pipe, the slurry, expected slurry density, and based on which we take a decision whether ultrasonic would be the best fit or a AERB exempted nucleonic density meter would be the best fit. So again, this is a solution which the industry power plant was looking for, and here we are with a solution for the measurement. So now let us just look at this density meter. So this is the source and this is the detector being installed. And what I was referring to that the sodium 22 source is as small as a button size, and you can hold it in your hand for 10 minutes. So over here, I would also like to brief you. So when we talked about nucleonic, we are talking about nucleonic density meter where there is a source and a detector. And there was a ESP ash hopper level measurement where we were again talking about only a detector but no source, because my fly ash was the source of radioactive ions. So I just want to clarify these 2 points over here, that this nucleonic density meter for slurry measurement uses a source and a detector which are exempted from AERB. Continuous level measurement for ESP hopper was using only a detector. There was no source and there is no approval, nothing required. This is the ultrasonic clamp-on density meter. The picture on the right bottom, what you see is ultrasonic clamp-on density meter. I would hand over, I would request Rajat to just enlighten us about the challenge 6. What we say is the walls for dry fly ash and ash slurry. Over to you, Rajat.
Yeah. Thank you, Abhishek. Yeah. So in ash slurry applications, one of the major challenges faced by the customer is transportation of ash, and generally fly ash and ash slurry. So the knife gate walls, generally conventionally installed in a ash handling plant, they generally tend to wear down due to the abrasion and corrosion of slurry. and like fly ash is a very abrasive slurry. So generally, in 2 months' time, conventional knife gate walls tend to wear down, and every 2 months, customer has to take a shutdown and replace the seat, gate, and the body. So this is one of the challenges customer is continuously complaining to us, and generally this shutdown time is quite long because these walls are heavy and replacement takes a lot of time. So, and it's very expensive also, like in fly ash what we have experienced in like so the fly ash is being transported to one of the cement factories, and replacing valve continuously after 1 or 2 months, it's very expensive, and they have to completely stop the line and then replace the valve. And we have a special knife gate valve for such applications, and in fact we are very proud of these valves and the performance of these valves. Abhishek, can you move to the next slide? Yeah. So we have this, we are tied up with a Swiss company, Tech, who are manufacturing these special patented knife gate walls, and we are proud to be associated with them and the performance which we get with these walls in ash handling plants, especially. So it's tremendous. In fact, these are special non-clogging walls, zero leakage. It's zero leakage. What when we say zero leakage, so it's better than class 6 bubble tight shut off. So we have this bubble tight zero leakage patented design of these walls. Then we have transverse seal, mechanically retained seal. The specialty of these knife gate walls is that under full pressure the seal can be replaced. In the next slide we'll show a small video where we will you'll see how we can replace the seal in full pressure condition. These are some of the installation pictures of our knife gate valves in fly ash applications. Abhishek, can you switch to the video?
Imagine
Voice, Ari? There's voice?
Yeah, voice is coming.
a valve that doesn't leak. Guaranteed.
So the specialty of these valves is in the gate design and the body design, which is a patented design of this company, Swiss company. As you can see, the gate design is a straight gate. Conventionally, the gate design is a 180-degree arc. As you can see in this, it's a straight gate with a mechanically retained seal between the two bodies.
While in service.
Like as you can see, there's leakage during operation after a year or two. So without in full pressure condition only, we can replace the seal kit. We have to just unscrew the two nuts and we can insert the seal kit. And again, our valve is good to go.
Against emergency downtime.
This helps in reducing the shutdown time. We do not have to take the valve out and then do the replacement of seal kit. As you can see, again, in full pressure condition, the valve is good to go. We have a unique transfer seal. This is according to applications of the customer. So in ash handling plant, we have a unique transfer seal. This can be replaced in full pressure condition.
While opening or closing. Unique gate geometry. Promotes self-cleaning.
As you can see, I told you this gate is a straight arc. So automatically the design of gate helps in cleaning of valve when it closes down.
Self-cleaning without flush ports. Complies with AWWA C520-10. Reduced chest cavity. Prevents solids from jamming.
As you can see, this is automatic without flush ports. When the valve closes, automatically it cleans the valve and closes down. This is because of the special design of body and gate which they have.
It's full pressure, both directions. Non-rising stem saves space. Installation in tight locations.
In fact, these walls are one of the walls which are for petrochemical industries. These are being suggested by the licensor of the technologies, like DuPont and Belco. And in fact, in various Indian petrochemical plants also, these walls has been replaced.
Ongoing cost savings.
The conventional walls has been replaced by these walls. When the licensor have recommended our walls for
Plug back,
these applications.
which
In
results
fact, in NTPC plants, also various NTPC plants, by the performance feedback of various customers from other NTPC plants, they have replaced the conventional walls with our knife kit walls.
EIP. I hope there was some information which was useful to you. If you have any further queries, you can write to us, email to us, or call us on the below numbers. You can take a note of these numbers and you can approach us anytime. From the team of EIP, we would like to thank you for your patience for this presentation.